today is Pi Day. And you may think, oh no, it's not Pi Day because that's March 14th and today is July 22nd. But in a lot of ways, we could say today is Pi Day. So of course, we have the number pi, 3.1415. I don't even remember the numbers because I don't, that may be a 6. I'm not really even sure. It doesn't really matter. And historically in the United States, we would write March 14th as 3/14/2023 or 2022 or whatever, and that's Pi Day. But this is a weird date format that mostly just the United States uses, where we put the day, the month, the day, and the year, but that's doesn't make sense, right? Because a month is bigger than a day. So a lot of other places would put this as 14/3/23 and 14. So this is kind of like, look, 3.14 pi, haha, right? I mean, it works. I love Pi Day. Don't get me wrong. But 14/3 is not Pi Day, right? So that's 14/3. And so then you could say, well, what about 3/1, right? That would be the third day of January. Okay, 3.1. Good job. Or you couldn't do 3/14 because that's the 14th month and there is no such thing. So we have July 22nd would be 22/7/23, and 22/7 is approximately pi. It's actually a pretty good number for pi. So let's do this. Let's do P1 is going to be the percent error of 3.14, which is not pi. So I'm going to take pi minus 3.14 divided by pi. Right, and that'll give me like what percent error is it for that one. And then P2, I'll do pi minus 22/7 divided by pi. You could just do the division. I don't even know why I'm doing this. That's fine. Okay, so let's just do these. Let's calculate these real quick. So here's my calculator, and I'm going to do this one, parentheses, pi, right there, minus 3.14, close parentheses, divided by pi equals, and I get 0.0005, 0.0005. Yep. Okay, now this one, clear, parentheses, pi minus 22 divided by 7, close parentheses, divided by pi equals 0.0004. So that one's better. It's closer to pi than pi. And that's not pi, right? Okay. And so that gets us into, and I did this a long time ago. I did this like 10 years ago. I did a look at the fractional representation of pi. So the question is, that's a pretty good representation of pi. What other fractions work really well as pi? I mean, 23/7 is not good. 21/7 is clearly not good. That's 3. So, why is it 22/7, and are there better values? And so I wrote a computer program in Python, and I did it so long ago it wasn't online, and I want to redo that. And so here's what I'm going to do. I'm going to take the number d over n. And I'm going to start with d equals 1, n equals 1. And then I'm going to compare that to pi. If 1/1 is less than pi, which it is, then I'm going to add 1 to the top, right? Because then I'll get 2/1, and then I'll get 3/1, and then I'll get 4/1, and once I get 4/1, and it's it's greater than pi, I'm going to increase the bottom number. And I don't know why I wrote that as pi. So that's my plan. And then I'll just keep on making these fractions. Let's just see what happens. Okay, and I did make a graph. I want to remake that graph in Python. This was at least 13 years ago. I don't even remember how long ago it was. It was a long time ago. I've been writing Pi Day stuff forever. Now I have 2 Pi Days, so it's awesome. I'm using WebVPython because that's what I like. I'll give you the link to the code because that's what you like. So let's go ahead and make a graph. And I'm going to make a graph, G1 equals graph. I always like to do it this way. Title equals fractional pi, fractional representation of pi. I don't know, that's not the best title. And then my horizontal axis is going to be, I'm just going to, what did I do before? What was my horizontal axis before? I'm looking at my old graph. I did iteration number. Yeah. So just how many times, whether I increase either one. So let's call this just n. X title equals n. And then y title will be d over n. And let's put this width equals 500, height equals 250. And then F1 equals G curve, color equals color.blue. Okay, now we're ready. Pi is already built in, just so you can see this. Print pi. Now, if you're not doing, WebVPython, then you're gonna. I don't think pi is in there. I think it's in NumPy, so you have to load NumPy. But I have WebVPython, so I don't have to do that. So let's just say n equals 0, d equals 1. Ooh, I need another n. Let's call that n. And then n equals 1. So capital N is my count number, and then d is my denominator, n is my numerator. So let's do this while n is less than 50. I don't know. And let's just pick this. So I'm going to calculate my fraction. I'm going to say f equals n over d. If f is less than pi, then what did I say? If it's less than pi, I'm going to add 1 to the numerator. So n equals n plus 1. Else, add 1 to the denominator. D equals d plus 1. And then I'm going to say, I'm going to plot that, but I'm going to say, I'll plot it first. F1 dot plot nf. And then I'm going to add 1 to n. N equals n plus 1. That should work. Let's just see what happens. I'm not really 100% positive. Okay. Nice. Now, let's add another graph just so we can see where pi is. But you can see what's happening here. It's too small. It's too big. Actually, it's too small again. Too big, too small, too big, too small, too big, blah, 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 like that. It's kind of cool. So let's make another graph. P1 is G curve. Color equals color dot green. That's the way I did it before. And this is just going to be plotting pi. So I'm just going to say, I can just plot 2 points. So P1 dot plot 0 pi. P2 dot plot 50 pi. So I'm just going to put 2 points on there and connect them with the line. That's all I really want. But it'll look cool. And it blew up. Something bad happened. P2. That's why did I do that? That's kind of weird. There. So there's my value of pi. And you can see these numbers, that the numbers above are a lot closer, which is kind of interesting. I'm not sure why. This number right here is very, very close. That's the, I don't know what the number of that is. That's probably that 22 over 7. No, it shouldn't be. It should be, because if I have n is 27. If n is 27, that's my 27th change. So, okay. Now, I did make another graph. I'm going to do the same thing, but I'm only going to plot points if it's better than the previous point. And I'm going to start with d is 2 over 2. So let's make another graph. Let's just use the same graph. I'm going to make this g dots. And then I'm going to do this. So let's say, and let's start with both of these as 2. Right? Because why? And then start n as 2. And then I will I need my best, right? So I need to find the best. So let's say the best is what I have right now, which is 2 divided by 2. No, 2 divided by 1. Let's do 2 divided by 1. So 1, because that's stupid. So 2 over 1. Actually, let's do 3 over 1. It's still too low. And so this is going to be 1 over 1, and then it's going to be 2 over, so this should be 3, I think. Yeah. It doesn't, if we're off a little bit, it's fine. Okay, so that's my best value. It's going to be 3. 3 over 1. Now, I'm going to do this again, but I'm not going to plot it. I'm going to say if, so let's say error. Let's say, what are we going to call this? Diff. Diff is going to be pi, the absolute value of pi minus f. If no, I need to have my difference. Okay, let's see. So I need to say, is this fraction better than the previous one? And so best. Oh, I need this should be the best difference. Yeah. So I'm going to say absolute value of pi minus n over d, or 3 over 1. That's where I'm starting at. Okay, so if the diff is less than best, then I'm going to plot it. And I'm going to make best equal diff. That should do it. And that's just going to be 50, but let's just see what happens. I think that should work. Okay, that worked. So you can see here, there's a better number, a better number, a better number, a better number. It keeps getting better. It should never get worse. I had over here, let's start this at 1 and 1, just to see what happens. And this is going to be 1. Okay, so there's, see, I don't think this n really helps, but there's n, and this is important right here. No, that one's really good. I should print out like the fraction. How could I print them as a fraction? Well, let's just keep going. Let's just keep going up to n equals 100. See what happens. Okay, that's important, right? Because, oh, it stopped at n equals 50. Why did it stop? Oh, did I not? N less than 100, but I'm plotting. What if I do that 1,000? It stopped for some reason. Okay, there you go. N is only half as much as it should be. That's kind of odd. Maybe I am plotting n. Wait. So look right here. We get a bad representation. It gets better. It gets better. It gets better, better. Then right there, until way over here, can you ever get something better? So that number right there is the best. So that is n equals 30. Let's print out this. Let's go with, I want to print like f and d. What if I just printed f versus n versus f? N versus, let's just try that. N, D, N. I'm going to plot denominator versus numerator. Let's see what that looks like. Okay, so that's good. So you can see right here, I have 20. What is that? Is that the 22 over 7? That must be 22 over 7. 22 over 7. Yeah, because I'm adding it beforehand. So that's 22 over 7. That, you don't get a better number until you get over here, which is that not right? 55. Wait. The point is that 22 over 7 is really good, and you don't get a better number till later. Now, there is something else very interesting you can look at. Most of these cases have at least one of the numbers as a prime number. Why? Because if you have a prime number, if you're dividing or by a prime number or dividing a prime number, you're not going to get you're going to get number that goes on forever. Pi goes on forever, so that helps, right? Okay, so I remade the graph. That was really my main goal. And I will save this, even though I messed it up. Fractional pi. I will give you the link to the code. I'll give you a link to the original blog post too if you want that. It was written a long time ago, 2010, which is basically ancient. So, okay, happy Pi Day.